I will. Do you want to start or do I start there?
You can go ahead.
Cool. All right. Thank you. Okay. So welcome everyone to the webinar. We're going to be talking about Pinecone Serverless, a little bit of what is behind Pinecone Serverless, why we did it, and also a few sort of tips on using it or getting the most out of it, at least. So let me just move this. Okay, cool. So let's jump straight into it. So AI at the moment, what we have, or at least what we can mostly see out there at the moment, is what I like to think of as a V1 of AI. So that V1 of AI, it includes intelligence, which is essentially LLMs, and it includes knowledge, which it covers quite a few broad things, but at least in this sort of V1 of what we have at the moment, it's mainly RAG and vector databases. And that's kind of where we are at the moment. And what we rarely see that in order to kind of make AI like competent and reliable, you tend to need both of these, and a few other components in there as well. So when I'm talking about both these components, you have your LLM. That's what we would refer to as parametric knowledge. It's basically knowledge that the LLM has learned during training. And it gets us so far, but at some point we end up needing other kind of like support for the knowledge of your LLM. And most of that comes in the form of source knowledge, typically through RAG, retrieval augmented generation. Now, the reason that we need both, though, is that LMs alone they're very good, but they're just not enough for like reliable application or something that seems like genuine intelligence. The reason that I say that is they're not steerable. Like a LM just kind of goes off the rails. Most of the time they're good, but some of the time they're just not at all. We've all seen. I think it was BPD or some other company, maybe Chrysler as well, where they've had their chatbots, and it just it offers people great discount and all these sort of things, or offends people. So they're things that we don't really want. Another big issue is obviously hallucinations. I mean, we've all spoken about that, and I'm sure very aware of that. And another thing is up-to-date information. LLMs take a long time to train. So in order for LLMs to work well, there's all these other components that we need in order for them to be reliable, to be able to do these other interesting things. Now, RAG is really the most popular by far of things that we put with LLMs in order to make this more broadly applicable AI. And that's why I say that RAG is like the V1 of AI. I think there is a sort of a broader, there's RAG, but we're also now seeing more complicated forms of RAG. We're seeing different components that you add to your RAG pipelines. All these different things are being added into that AI ecosystem, that AI stack. But the V1 is still RAG. Okay. And that is definitely something that we've seen. So like I remember before ChatGPT, it was all semantic search, and there was, I think, the equivalent of RAG back then. We did have RAG. It was terrible. I mean, it was okay. Even like a little bit before ChatGPT, we were starting to get good RAG, but it wasn't anything special. But then, before really GPT-3 came, RAG was just not very reliable at all. It was pretty bad, and we just relied on other forms of essentially question answering with semantic search and more extractive models and generative models. And because of that, what we really saw on Pinecone, and this is from my mental model of the share of Pinecone use cases back then. It's not definitely not accurate. But the vast majority of them were semantic search. We had some like image search, video search, those sort of things, so multimodal, some model training, and that was growing at the time. And then there was RAG. I don't think it would even have been as big as it is on this chart before ChatGPT. It's probably smaller. And then ChatGPT comes along, everyone wants to do RAG, and it's just, it's like that's most of the use cases now are RAG or RAG related in some way. So it definitely caught. However, okay, we have this sort of pairing for AI between knowledge and intelligence. But it's, well, basically what we see is that the intelligence component has become increasingly cost effective, right? So there's, okay, Text DaVinci, and this was one of the cheaper models at the time. Text DaVinci was $0.02 per 1K tokens. Now, what we're looking at for input tokens, it's 40 times cheaper with the most recent GPT 3.5 for outputs. Still pretty big savings, not quite as much, but really not too bad at all. And we've also seen the same with embedding models, like a very similar, like the massive decrease in price for those. So the intelligence part of this, intelligence and knowledge stack for AI has become, it's getting very cheap. However, with knowledge, it's mostly just stay the same for the vast majority of that time until serverless, which we'll talk about soon. So there has been a disconnect between those two. And sorry, I forgot to change slide. So this is the knowledge chart. So in order for the knowledge component to serve AI well, it should really become more cost effective, like we've seen with the intelligence component. And serverless is our answer to do that. So let's talk a little bit about the problem with, why have we seen that? If I go here, why have we seen that knowledge has stayed the same, whereas intelligence has decreased, right? And the main reason for that is that the traditional approach used by vector databases to make vector search scalable and usable is this scatter gather architecture. So the idea is that you have this executor, which is kind of like your planner or router, something along those lines. Essentially, it's like the brain of your system, and you send your query into your executor, and then your executor scatters your queries among all of these different shards they're essentially their own individual vector indexes. And what you can do with this is you can scale to you can scale to billions of vectors, and it works, right? And that's great. So your query goes out, goes to all these shards, every shard returns some results, and then you gather all those responses and your executor puts together your final response. So that's a traditional approach to doing this. The problem with this is that it's fundamentally limited, because with every query, you're scattering your query among all of these different shards. So you have to access every single shard, and you have to search across every single shard. And because you're searching across every shard, so when you perform a search, it has to be on a compute instance. And a compute instance is expensive. So you have all of your data on compute instances, and that's expensive. And yeah, I mean, it's expensive. And because of that, what we really need is a way of decoupling those two things, decoupling the storage component and the compute component. So we want to be able to just store the majority of our data in cheaper storage. And of course, then just use compute for what we need to use compute for, i.e. the search and retrieval. So, well, how do we do that? So the first thing is just identifying where we need compute. So, okay, well, how do we do that? I mean, you take your index, and there are different ways of doing this, but one example is you take your index and you partition it into smaller partitions, right? So you have your index, partition it in smaller partitions, and this is generally based on geometric proximity. So for those of you that are that have used these techniques before, you can think of IVF indices or Voronoi tessellation, okay, and you'll get this sort of thing. So by doing this, what we're able to do now is, okay, actually within each one of these cells that you can see here, so you've got a little yellow dot, that's like a centroid. And within that centroid, there can be many vectors, okay, just to be clear there. Okay, so within each one of those sort of square cell things that you have, there can be many vectors. And what we can do with this is that we can take a query, we can put it in there, and we can look at the clusters, and we can see, or the centroids, and we can see which of those centroids are most similar to our query. And then we just look within those cells. Okay, so we're limiting our search space, essentially. So we do that. And because we've done this, right, we can say, okay, I go back here. If you look at this sort of the orange area, you can think of that as being where most of our queries end up going, because this is something that happens when you have a vector index. A lot of your queries go to one part of that index or a few parts of that index, but the vast majority of your index ends up pretty quiet and empty. So you can actually see, what would be like the hot areas within your index. And because we partitioned it, we can say, okay, these partitions are more commonly accessed compared to the other areas, which are less frequently accessed. So then what we can do is we say, okay, the hot parts of the index, we want to put them into our compute instances. And then everything else we put in storage. So, well, by doing that, we're able to store all the bits that we don't really need, or the parts of that index that we don't really need on cheaper instances, whilst still keeping the latency performance high with the compute instances, just focusing on what we really need on compute. So when it comes to query time, we have this sort of new structure. And this is simplifying a lot of things, but at a high level, we have our router. So that would kind of be it would be the similar to the executor from the previous more traditional approach. So you have your router, and the majority of queries that go through your router are going to end up going to the like hot partitions of your index. And those hot partitions, we put them on the compute units. Okay, so we get fast results very quickly. And they're also generally geometrically similar. Okay. But we might, every now and again, we might see, okay, let's, I'm not sure if you can see my mouse. I hope you can. But this little cell here, so I'm looking at the left, there's like just choose one white cell. Maybe one of those is also like a hot partition. Then what we might end up doing is across different indices, and this can be across customers, right? So we can actually do this, across many different indexes that are actually separate. What we could do is we could take another hot index and we can put it, or we can allow it to share the hardware of another hot partition. So you put all of your hot partitions that are very frequently accessed on the same compute units, and then we're saving even more on costs because you're essentially just you're cramming all of the partitions that are accessed very often into your compute units. So you're making the most of them and you're saving costs, and then obviously those costs you pass on to your users, which is you guys. So yeah, that's what we have there. Every now and again, we are going to get a query that does go into the sort of more cold regions of our indices, and they will end up being on storage units. So that's where you have a bit of a cold start on your query. So the storage unit, you have to move it over to a compute instance, and then you perform your query, and then you return the result. So every now and again, you will get a slower query, but it's pretty rare. I mean, we actually have some numbers later on in the presentation, so we can look at those, but it's very infrequent. So we've now decoupled our compute and storage, which is great, but there are still some other problems that we need to handle. Probably the biggest one, I think, is freshness. So with what we've just done, right, it's kind of, I mean, it's far more complicated than what I have shown in those little charts. It's very, watered down, simple version of it. But there's a lot of clustering going on, figuring out, or moving around different parts of an index, restructuring that index, rebuilding it. So when you're adding new vectors into that, it can take a long time, right? You add some new vectors, you need to figure out, okay, where did it go? Do we need to recluster? All these things have to happen. You need to move them to different partitions. That takes time. And that obviously causes problems if, especially when you're pushing a lot of data, that can cause problems with your freshness, right? So you basically add some more new vectors, but then it's going to take a little bit of time before they are correctly organized into your index, into your partition index. So we need to find a way of just handling that. Now, the way that we are handling that is what we call the freshness layer. Now, when we go into the freshness layer, so we have some new data. Let's say we already have an existing partitioned index, so we're adding some more new data. What is going to happen is the new data is going to go into your freshness layer first, and it's also going to get written to some blob storage. It's going to go into there first, and we're going to make it available to you. Okay, so when you're querying, your query would then go both to the freshness layer, which is essentially like your cached new data or new vectors, and also your existing partitioned index. So it goes to both of those, and the results come from both. Okay, so that means you're getting much more fresh results on data that has just been added into your index. Now, at the same time that your new data goes to your freshness layer, also begins the process of being added into the existing partitioned index. Again, that takes some time, but once it is complete, it's in your partitioned index and it will be removed from your freshness layer. So using this approach, we're able to keep things fresh, okay, whilst also being able to optimize on storage and cost, as we've been talking about. So that's yeah, well, it's pretty cool. Now, I mean that I think that is sort of at a high level. That's what we have in the that's the new architecture of what we have for Pinecone Serverless. Now, what I want to do is talk a little bit more about, okay, the architecture is cool, that's nice, but I think for the majority of us, it's more of a, it's an interesting thing to know. But what is more important to us is, okay, how do we use Pinecone differently? Do we use Pinecone differently? Are there new features? All this sort of stuff. So let's have a quick look at that. So for the most part, at least within the Pinecone client, it is mostly the same, but there are some small changes. So I mean, as I mentioned, we've seen just a ton of RAG use cases. So there are a few features that are really focused on improving like your user experience when it comes to RAG. Like they are built for RAG. So that is new. And then there's also more flexibility in the way that you specify your environment or region. So for those of you that were using Pinecone before with the pod-based indexes, what you would need to do with every environment is that you'd have to basically you'd have to go into the console. So it's like the app.pinecone.io, like there, the web interface. You'd have to go into there. You'd have to set, okay, I want US+1, or I want EU, Southeast Asia, whatever. You'd have to set those within the UI. And then you come back to your code. Oh, actually, you have to pull in the environment and the API key. And then you come back to your code and go. Now you don't need to do that. You just API key, and that's all you need. You can, right now, there is only one region available. In the future, there'll be more. But we can set that just from the code, which is nice. And I suppose the other thing, which is more of a note that we need to be aware of, is there's no delete by metadata. Now, the RAG document management features do make up for that to some degree, but it's worth just being aware of that right now, delete by metadata is only in pod-based indices, not yet in the serverless. Okay, cool. So I mean, I put this link here. I probably don't expect any of you to write it down, but you will get these slides afterwards. So you're going to get access to the code as well. So I'm going to switch over to that quickly. Just give me a moment. If I can. Okay. Okay, great. Okay, cool. So let me smooth things around a little bit. Sorry. All right, cool. So we're going to just go through. I'll go through this quite quickly, but there are a few things that I want to point out that is new in the Pinecone client, which is not as obvious. Well, some of them are obvious. Obviously, your serverless spec, for example, it's pretty obvious. But there's a couple of mainly the document management stuff, which is not. It's not. I don't know if we've really announced it as such, but it is in there, and it's a really nice feature, especially for RAG. So we're going to mainly focus on that. So typical stuff, installing prerequisites. I'm getting this AI archive data set. Not really going to go through this too much, set from where it's relevant. So this is the bit that is relevant. So obviously, in RAG, what you are typically doing is, second. So what you are typically doing is you take a document and we chunk it, right? So for example, in this scenario, we have our AI archive papers, and we would take a single PDF, we'd break it down into like sentence length or paragraph length, chunks, and we would then embed those and put those into our vector index. Now, one of the, like, I think it's a cool new feature is the ability to list by prefix IDs. We can also list all IDs, which is a new one, which I know people wanted for a long time. So list all IDs is another one, but you can also list all IDs by a specific prefix. And I think not many people know about this yet. So here you can see we have this document ID. So this is for an archive paper. And then we have the chunk ID here. What we can do is we can structure our ID that we put into Pinecone like this. So we take the, I hope you can see that okay. So we take the ID as a common prefix, and then we just add like chunk ID onto the end of it, right? Which is, it's a nice thing we can do. So we do that with our data set beforehand. This is what I'm showing here. And then let's skip ahead a little bit. So creating the embeddings, we're using Cohere here. And then we create a serverless index, and we'll come back to those prefixes in a moment. So this is the other slight difference. We set our serverless index. We don't pass a environment anymore. Instead, we pass a region, and we do that within our code. Okay, so slight different approach there. Okay, yeah. Generally, I think this approach is simpler. Anyway, we go through, we populate our index. Again, not going to go through all this. But what I do want to show you is managing docs to RAG. So this is where the prefix and other things will come in. So the first thing I want to show you is listing all IDs, okay, without a prefix. So in order to do a lot of these document management or to use these document management features, what we have to do is actually use the Pinecone API directly rather than through the Pinecone, Python client. So when we're accessing the API directly, we do need to get the host name. So we do that here. So we're using we are using Pinecone client here, describing an index, and we're just getting the host name of that index, right? So it's what you can see in here. So we get our host name, and then what we do is we pass our host name into our URL. So we're hitting this URL here. We also, again, like as we would with the client, we have to pass in our API key. We just need to make sure we place that into the headers of our request here. And what we're doing here is we're getting a list of all IDs, right? And I think I'm relatively sure that for almost the entire time I've been at Pinecone, it's been the most requested feature. Serverless has added that feature, right? So we can now list all IDs. So yeah, you can see that here. Obviously, when you are sending or when we're returning that request to you, we can't give you everything. So we also include pagination, I think. Pagination, I'm not sure how you say that. So we include pagination maybe here. And we just set up a small, like a while loop that will go through and basically retrieve everything for us. So if we do that, we will, you can see here, sorry, we get pagination token, we go through, and then we'll get all of our IDs, okay? So I only uploaded 1,000 vectors here, and that now we have our 1,000 vectors. So that's getting all of our IDs, which is a nice thing, not directly related to RAG, but it's a pretty highly requested feature. The other one is, and this one is the RAG thing, and this is what I mentioned earlier, is using those prefixes. So the prefixes work in a similar way. So we're listing all of our IDs, but we're filtering for a particular prefix in our ID. All right, and this is great. So I mean, if you there's multiple tiers of prefixes you can use here. So in this example, we're just using a symbol prefix or a single prefix doc ID. But we could also do something like if we wanted to include maybe like sections, or maybe have like a summary as a separate part of a document or something, you could include a second ID here. I'm just going to say I don't know, sub doc ID, you can include that in there as well. And then what you have is multiple levels of like prefix filtering. Okay. But in this example, I only created one level of prefixes. So we just have this. So yeah, we pass that in, we list all of our IDs based on this prefix, and then we loop through it as we did before. And you can see now, so what I can do is I can get all of the documents that are, or all of the chunks that belong to this specific document here. Right, so this is the prefix I'm using. And I can see that's 33 of those, okay? Which is great. So now what I can do is I can list everything that's from a particular document, even though I've already chunked it. And we can also manage our data in that way as well. So we have all these IDs. We can obviously pair that with deleting or updating or whatever else you want to do. Okay, so a nice little new feature. Now, okay, here I'm just showing. Okay, we're just querying. Okay, so this is the same document. Okay, yeah, it's the same document that we have here. It's actually a book from one of our colleagues, Sebastian. So it has quite a few. It's all on archive, so it has quite a few like chunks in there. So it's a fairly big one. And yeah, so I'm taking that out. Is it the same one? Yep. So you see that's 408 chunks for that single book, essentially. And then if we want to delete just all chunks that are related to a specific document, we can do like that. Okay. And you can see, okay, we've got foundations of vector retrieval in the results here. If we come down here and we query again, we'll see that we don't have that anymore because obviously we delete it. Yeah, so that's on the sort of kind of new features in serverless that we, haven't really spoken about, which are nonetheless pretty cool. And yeah, so I think that's mostly everything. I do want to just show you some benchmarks very quickly. There are a ton of benchmarks in here. I think there's probably like there's around 10 slides of benchmarks here. I'm not going to go through all of those. So I think you'll probably leave before I finish. But I'll just point out some of the more interesting ones. And then if you are interested in the rest, you can see them when you get these slides later. So we're not going to go into that. So cost of queries. So this is probably the most important one for, I think, everyone. So when you're looking at pods, the amount that you're spending per month. So what you'll see is for smaller indexes, you're still saving money, but then that impact becomes more pronounced as you scale up. So this 900 million Falcon web data set at the bottom here, I'm not sure what that is. It's like a 5x cost savings there, but this is like at high query throughput. So for a lot of use cases, at least what I find, especially with RAG, is that there's not always necessarily a lot of high query throughput. And the lower your query throughput is, the more you're going to save on this. So in a lot of actual real world use cases, this saving is usually a lot bigger than what you can see here. So yeah, you can see some actual numbers here. So for the Falcon web data set that I just pointed out, so 530% cost reduction for a very small data set. So this is 60K. It's still pretty high, like 641% there. Serverless is generally faster, latency is better. There is this, so the cold start latency is something that you do have to be aware of. So this is when you're first making your first query. Recall is still pretty good, as you can see. And actually so you're looking at P5 here. So it's basically like the worst performers across pods and serverless. And essentially what you see is that the worst performers on pods are worse than what you generally get for serverless. Serverless, even for the occasional bad query you get, still performs better. Yeah, for P95, they're mostly the same. And yeah, I think that's basically everything. So I think we want to just jump into questions. So for any questions you do have, just add them into the. I'm going to pull them up now. Just add them into the Q&A section. And I'll go through them. Okay. Cool. Okay, so from Bob, he has a question on. So said, I'm interested in hearing about the integration of serverless and Canopy, as well as an update on the Canopy and its document type support. So the document type, document type is, I think that's further down the line. I assume you're referring to whether they will begin supporting PDFs and or videos, different types of documents that you can have there. So I know that is in the pipeline, but it's probably a little while away. However, for the integration of serverless and Canopy, that is in there. So as far as I know, it's been out since day one of serverless. So we do have that. Okay. All right. So Fatsal is asking about migrating 1,000,000 vectors to serverless on Pinecone without any downtime. So there are some like unofficial tools out there at the moment that you can use for migrations. I would, I would look into them, but just they're not official, so just be aware of that. But there are some migration libraries out there already. Otherwise, what you can do is if you don't mind waiting a little bit longer, we are going to we're going to create our own migrations, so you will be able to handle that from within our own ecosystem relatively soon. I don't know the exact dates of that, but probably I think it might be a month or so, maybe a couple of months until we get there. What's okay? So Cheddy is asking what's better, Anyscale or Replicate. I don't know. I've kind of I've used Anyscale a small amount and it's good. Replicate, I have no idea. Sorry. Okay, so a man is asking. He's new to AI. He's learning a ton. And he's looking at services like Pinecone, DataStax, AstroDB, Vectara, and it's difficult to determine why we'd use one over the other. If possible, please briefly describe or briefly speak about the differences and similarities. So, I think there's like two broad categories that you can apply here. There's the bolt-on vector databases. Did I say bolt-on vector databases? So that would be like the Postgres offering as a super base. That's a bolt-on, and then you have more the native vector databases. So the main differences between those is generally one of performance and scalability. You can argue for a bolt-on that maybe it's if you already have like Postgres, for example, it might be easier if you're working at small scale, not at large scale. If you're working at small scale, it might be easier to just use a bolt-on. But then when it comes to if vector search is actually like a key component of whatever you're building, generally the native vector databases are going to handle that better. So they're able to scale more. The performance is generally better. Yeah, what you tend to find with the bolt-ons is that they don't scale very well. That seems to be the biggest weakness of those. So it's just something to consider. Like for quick and easy, for like very small data set, maybe it's fine. But obviously, once you start getting serious and adding a lot of data in there, you probably want to be looking at a native vector database. And then when you're looking at different vector databases, So you've got Pinecone data sites here in Vectera. Probably another thing you want to look at is serverless, right? Are they serverless or not? If they're not serverless, they're going to be more expensive. If they're serverless, they're cheaper and generally more scalable. So yeah, I would probably look at those, and I would try and look, if possible, depending on what your use case is. If you're going at like big scale, look for benchmarks that are at scale, because most of the benchmarks that you see out there are like tiny, not very realistic use cases. So they're not always that accurate when it comes to a real world scenario. So I would recommend doing that. Okay. So from Jackson, so Jackson's asking, will serverless let Pinecone offer a larger top K? We use Pinecone to rank documents for classification, very similar to the GONE case study. Right now, once we exceed 10K, we have to do the ranking in our own code. So I'm not aware of a planned increase to the top K. It's kind of interesting use case. I would probably recommend maybe reaching out to someone and reaching out to support and just kind of sharing this use case, because I don't think I personally, maybe product or customer support are more aware of these things. I don't think I've personally heard of anything going like 10K as your top K. That's pretty high. So I think it would be pretty interesting for us to hear about that. And yeah, maybe it's something that we end up adding to the roadmap. If it's not already there, maybe it is. So Marina is asking, how can we get around no delete by metadata? It can be a little frustrating at the moment sometimes, but generally what I find is most of the when I usually do delete by metadata, at least for RAG, a lot of the time I'm deleting by a document ID or some form of ID, and we can use the prefix ID deletion that I shared, or alternatively, what you can do is search by you can search with a filter, and then just pull in IDs that way. Although that's, I would say, not as ideal as using the prefix ID approach. So if you can get that metadata field into your prefix, that is the sort of ideal solution for now. In the future, I'm sure we'll get that back on serverless as well. Okay. Cool. So Marina again is asking, would we have to retrieve all the vectors associated with some metadata and delete each one? Oh, okay. Yes, yeah. So continuing the previous question. Yes, you can. I mean, so again, it depends, right? If you're doing the prefix ID, you can do that. If that's not possible, yes, this would be the way you'd have to do it. So you'd have to retrieve all the vectors associated with with some metadata, extract the IDs, and then you delete each one. That is, that's the workaround at the moment. Igor is asking, would it be a recorded session? So this is recorded, and we will share the video on our YouTube later. Okay, so Craig Templin's asking, what are the use cases for querying by doc ID versus metadata? So you wouldn't query. So querying, you do querying by metadata, right? So you add filters to your queries. You don't query by doc ID. Okay, so if you do want to query by a particular document ID, you need to add that document ID into your metadata, and then you query as you usually would. Right? So there's no differences to how you query there. The only so the doc ID thing is purely when you're managing documents. So when you're when you are um, reading documents, updating documents, or deleting documents, that's where you'd use the prefixes. Okay. So Armando is asking. So he said Canopy will no. He's asking if Canopy will no longer be needed in serverless. So um, I mean, no, I think maybe it's a misunderstanding somewhere. So Canopy is more of like it's more of a framework built on top of Pinecone, okay, for specifically for RAG. So you can use pod based Pinecone underneath that, or you can use serverless based Pinecone underneath that. I would recommend serverless, but it's up to you. So there's no difference to there's no change to Canopy on top of that. Mainly, the only difference you're probably going to notice is your costs more than anything else. Okay, so Livu is asking if your query needs to hit partitions that are in storage. Will that delete the overall response? Sorry, will that? Oh, delay. Sorry, will that delay the overall response ranking, and by how much? Yes, it can. So generally, the partitions that are in storage versus compute, the ones that are in storage are the ones that just are very unlikely to be queried and to be returned. And this is something that we've logic that we have built up over seeing like many tens of thousands of users using Pinecone. What you tend to see is that within an index, there's certain areas that end up getting that are just queried and returned more frequently, and other areas that are mostly just ignored. But what occasionally, yes, you will end up hitting one of those sort of uh, the areas that are mostly ignored. And as soon as you do hit that area that is more ignored, we register that. You can see that it's been hit, and if it does begin getting hit more frequently, it will get moved to compute. So the first few times, yes, it's going to be slower, but yeah, after you've done that a few times, it will speed up. Okay. Cool. Where else should we? Okay, so Heinley is asking for splayed models, so hybrid search. Did doc say there's a meaningful difference between pod-based and serverless index? Yes. So he's asking what is the difference? What are the consequences of those differences? With an example, I don't have an example. All I can really say is the way that the hybrid search works on the back end is different because there's many different ways that you can do hybrid. And given the new architecture, the old way of doing hybrid is just it's not compatible with the way that things are set up at the moment. Maybe that will be changed in the future, but for now, there's just a different approach to using hybrid, and it just means that you might get different results, and there's not really any way of saying whether your results would be better or worse. It's more a case of you just need to try it and see what the impact is there. For a lot of use cases, there probably won't be a significant difference there. Okay. So Tony is asking, our use case is a product catalog that has attributes such as stock or price that update daily. Are there some special considerations for this case? I don't think it's necessarily any special considerations. I think the one thing I would say is that given that you're not frequently, I mean, you're writing data daily, but that's not too frequent. So, I mean, what you find with serverless is that write units. So when you're writing data, it's more expensive than read units when you're reading data. So the one thing that you'll probably notice is that things are a lot cheaper. That would mainly be it, I think. Okay. So Olivia is asking if every query happens to hit storage, will it be slow overall? So it's the earlier question. But he's asking, can we configure how many compute storage partitions we have? So all of that's kind of done automatically. There's no way of configuring that at the moment. But as I mentioned, like if you keep hitting storage all the time, it's gonna move it across over to compute. And Tommy's asking, are you opening graduate level jobs for reg development? I don't know, but you'll be able to find out if you go to the careers page of Pinecone. Okay, and then last question. Okay, last question from Bob. If I wanted to get started with Canopy and need to support other document types than the currently supported document types in Canopy, what would you recommend? Probably I would use unstructured. It's a very good library. Llama Index or also have a new, I can't remember the name of it, but they have a new library for processing PDFs, and in particular that's kind of interesting because this new library for PDF parsing is built specifically for RAG, and Llama Index are pretty, they know their stuff when it comes to RAG. So that's also pretty interesting. But for a broad range of documents, I would definitely recommend using unstructured there. Yeah, I mean, that's all the questions. So I think that's everything. Yeah, thank you for joining us on this. We'll make sure we send. Well, you'll get the recording on our YouTube channel probably tomorrow, and you will get slides to your inboxes. So